प्रेशर ऑफ कॉन्वेक्स एंड प्रेशर ऑफ कॉनकेव। उसके बाद we did the कैपिलरिटी का
Mhm.
कॉन्सेप्ट, जैसे वो कॉन्टैक्ट वो सब कुछ यू आर टॉट। उसके बाद ये दिया था, if angle of contact is lower than 90 then liquid will rise, if angle of
Mhm.
contact greater than 90 then the liquid will fall in capillary tube.
Yes, correct. I have seen your notes also. That is all correct.
Oh, oh.
Just a minute, I'm coming. Okay.
Okay, sir.
Yeah. So today we have to do the last topic of here, and that topic name is capillarity. Okay. Today we have to do capillarity. So I told you last class that the liquid basically rises or falls depending upon their angle of contact. Today is 13th or 12th? 13th. Na? Okay.
13, huh?
So capillarity is the phenomena, if I write the definition, phenomena of rise or fall of a liquid. The phenomena of rise or fall of a liquid in a capillary tube. In a capillary tube is called as capillarity. So if you have a liquid here, let's suppose I take two types of liquid. And this liquid has angle of contact more than less than 90 degree, and this is a narrow tube that is called as capillary tube. So if the angle of contact is less than 90 degree and the surface is concave, then the liquid will rise like this. Surface will be concave and liquid will rise. Similarly, if I take a narrow tube here, and in the second case, what I'll do, I'll take such liquid which makes a convex surface. As if you look from outside, it makes convex surface. Then as compared to the surrounding, the level in the tube decreases like this, like this. Okay, so this is the level here like this. There are two types of, here you can see it is rise, and here you can see the liquid level has fall. For this, angle of contact is less than 90 degree, and the meniscus is concave meniscus. For that, angle should be more than 90 degree angle of contact. This is called angle of contact. And this should be convex meniscus. It should be convex meniscus. It happens with whenever water is kept in glass, and this happens when mercury is kept in glass. Mercury is kept in glass. Okay.
Okay, sir.
Done.
Yeah, sir. 1 second. Yes, sir. Done.
Okay. Now, how much liquid will rise? That formula we are trying to derive. This is true for both in case of rise or fall. So let's suppose you have taken a tube here, and I'll take the first example where the liquid is rising, like water glass interface. So as we know that the surface will become convex because it is water in glass. So what happens, why the level will rise there? Because we know at the pressure at the concave side is greater than pressure at the convex side. So this side here, more pressure is there. If I say pressure P1, and if you take just inside here, pressure will be more. This pressure P2 will be less. Concave side more pressure, convex side less pressure. So here you can see this pressure is here. If I write, uh, pressure will be less. Now, if this height, if I take as h, then what I know that the pressure P concave minus pressure convex is called excess pressure, and that will be 2 into surface tension divided by R. R is the radius of the meniscus. Now, how much excess pressure will be there? So we know if the liquid has a density rho and height is h, so the extra pressure should be rho g h. And that extra pressure, excess pressure from our formula of height, and excess pressure from our formula of last class that we have discussed inside any drop, 2t by r. So that is 2t by r. If I say h formula, it becomes 2t by rho g r. Now here, what is R? If I draw this little bigger here to make you understand, let's suppose this is, sorry. Let's suppose this is the meniscus here that I have drawn in this tube here. Let's suppose this was the tube. Slightly, just I am zooming slightly, understand. So R is what? R is this center, this the meniscus. If you complete this sphere, then the radius that you will get, this is called R. That means here T is surface tension of liquid. Surface tension of liquid. Rho is density of liquid. Density of liquid. And R is radius of meniscus. Here also you can draw in short. This is the R. Radius of meniscus. It can be concave, it can be convex. But many times we have been given the radius of the tube. Now, if you see this diagram closely, this is the radius of the tube. Now, tube, if I draw, this is the tube. So this will be the radius of the tube up to here. Okay. This I can write as small r. This is the radius of the tube. And you know that the tangent that you draw at the surface and the angle of contact and the wall of the container, this angle is called angle of contact. So here theta I am writing as angle of contact. Now if this angle is theta, this becomes 90 minus theta. So this again becomes here theta. So R relation, you can see this is a right angle triangle. So I can use here cos theta equal to base upon hypotenuse. Base looks small r. What is small r? The small r is radius of the tube. Radius of capillary tube. Cos theta equal to base upon hypotenuse. So in place of capital R, you can use here R by cos theta. And this value I am trying to put in this equation. So that equation rise of liquid H formula is 2T divided by rho G capital R. I can use as small r by cos theta. Cos theta will go up. So what you get here, the height formula is 2t cos theta divided by rho g r, 2t cos theta divided by rho g r. This is the formula for fall of rise or fall of liquid in a capillary tube. In a capillary. Understood, Neil?
Yes, sir. Yes, sir.
Yeah. From here you can write.
Yes, sir. Done.
Okay.
Yes, sir, done.
Okay. So now this chapter is completed. You have not sent any exercise, so should I take few questions from my side? Have you sent? No, you have not sent no, any exercise material.
No, sir, I don't think so.
Okay. Can you see these questions?
Yes, sir.
Okay. The first question is here. First question, you can see the pressure difference between A and B, right? And the container is going upward with some acceleration, correct?
Right,
And you
right.
have, yeah, and height is given h. First, you draw this diagram. This is basically, if I write here, it is a container filled with some kind of liquid, and the container is going upward with the acceleration g by 2. And you have taken 2 points here. You have taken 2 points. One point is A and other point is B. The height between them is h. Normally, the formula says that uh, if you go at the depth B, then the pressure increases by rho gh. But here you don't write g. You if there is some external acceleration, we write g effective into h. Now, as the lift is going up, then the pseudo force will be acting downward. If you remember, if a system goes up, then the normal acceleration downward is g only. But the pseudo acceleration, that g by 2, will also act downward. So the total acceleration downward here, that is g effective, will be g plus g by 2, and that is 3g by 2. So from this equation, I can write pressure at depth B is pressure at A plus, in place of G effective, you have to use rho 3G by 2 into H. That means the pressure difference, that is PB minus PA, should be 3 rho GH by 2. That should be the answer. Okay. Understood?
Yes, sir.
Okay, so here I think second option is correct. Have you done?
No, sir, once again. Yes, sir. Done.
Next question says if equal masses of two liquids of density d1 and d2 are mixed together, what is density of the mixture? Masses are equal. Two liquids, they are having different density, d1 and d2 are mixed together, then we have to find the density of the mixture. So if I say equal masses of two liquids of densities d1 and d2 are mixed. So we have to find density of the mixture. Density of the mixture. So in that case, if I have to, we know that formula is density formula is total mass divided by total volume. Total mass by total mass. Individual mass try to find is it is given mass is equal. So I can write here. Let's suppose one has having mass m, other is also having mass m. And the volume is not given, but mass and densities are given. So I can write here first volume will be, that is I can use here V1 plus V2, where is the total volume. So this is m plus m, I can write 2m. For first volume, formula is mass by density. So m by d1. For second also mass by density, m by d2. Because mass for both are same, but densities are different. So here, this is 2m. Here m I can take common. It becomes here 1 by d1 plus 1 by d2. M cancel. Then 2 divided by d1, d2, you can take the reciprocal. Not like this. I can take the reciprocal d1, d2, and then it will be d2 plus d1. That means the final answer should be like d1, d2 will go top, 2 d1, d2 divided by d2 plus d1. Understood?
Yes, sir. Understood.
Yeah, please write.
Sir, could you scroll up? Thank you. Yes, sir. Could you scroll down? Yes, sir. Done.
Okay. Now, question number 3 says an incompressible liquid is enclosed with two frictionless pistons, one of a cross sectional area A and other of cross sectional area 4A. When the narrow piston moves by a distance h, the wider piston moves by how much distance? Here at A, you have applied a force F, it looks like, and we have the options here. So the third question is like this. So we have here you are applying a force F. Here the cross sectional area is A, and here the level has gone down by some height h. Here the cross sectional area is 4A. Okay. And what force here will act, that we don't know. And also they are saying that how much height here it will go, that also you have to tell. This much height, if this side level goes down, this side level should go up. H test. Understood?
Yes, sir. Understood.
So what I'll do, I'll take this horizontal level here. If you take at this point and at this point, pressure should be same. So this part is H. So here this will be also H. And at this pressure density, if I say this is same density here, at this point at height H. So let's write this point as I can write as M, and this point is N. They are at M and N are at same horizontal level, are at same horizontal level. And you know that if the container is at rest, if the container is at rest, then at same horizontal level, we have always the same pressure. So at M, pressure at M should be equal to pressure at N. Now, pressure at M should be, if I say, it will be rho G H, rho G H. And this side, if I say, it is H plus H dash. So I can say here it is rho G. This side is H. Or pressure, we can also say that the volume remains same. Whatever volume has gone down, okay, that is volume of liquid that is went down. This is A into H. And here the volume that will go up, volume of liquid went up. Okay, so went up, if I say here This is H dash, and area of cross section is 4A now. So I can say here H dash into 4A. So both you make equal the liquid that has gone down and the liquid that has gone up. I think A gets cancelled. So what we find that H dash is actually H by 4. Okay.
Okay. Okay.
Is that it?
Yes, sir. Done.
Okay. Question number 4 says, from the following figure, the correct observation is what? The pressure on the bottom of the tank, uh, A1 is greater than at the bottom of the second. Second option is the pressure on the bottom of one is smaller than the bottom of the tank 2. Third is the pressure depends upon the shape of the container. And 4 is the pressure on the bottom 1 and 2 will be same. Now this answer you can give. Just try, tell me. Question number 4, read carefully and tell me which option you think that's correct. And be quick, please. Have you understood the question? Neil, you understood?
Yes, sir. Sorry, my mic was on mute.
Yeah, yeah. Which option is correct?
Sir, I'm just solving.
No need to solve. Just read and tell me the answer. There is no writing and solving here. What do you think? At the bottom, which tank will have more pressure?
Uh, at the bottom, So second tangle period
Second will have more pressure.
should I think.
Okay. Why so? What do you think? Why? What is the reason behind it? Do
So
you think
just
that? Yeah, yeah, yeah. See,
um,
if this is pressure P1, this is pressure P2. You are saying P2 is more, right?
no wait, it will be the same option number 4
Why?
because the height of both of them are the same. So the gravitational constant will also be the same on both of them. If one was lower than the other, then that lower one would have more pressure.
Lower will have less pressure because pressure formula is rho gh.
Huh, huh.
Hmm. So both will have same pressure, right?
Yes,
But here, correct answer you have not given. Correct answer is the correct explanation is that pressure does not depend upon the shape of the container.
it is the same only for the option I told.
No, no, that is correct. But what is the reason? Reason you are saying some gravitational constant remains same and that all. That is, see, answers you give from yourself. If you search the answer somewhere, they can give the answer wrong. You think about what is there, what should I say? If you don't know, you can tell, sir, I don't know. That will be good. No need to be a little more smart. Okay. You be okay, I don't know what is the correct explanation. I'll answer. Don't worry. Here the correct explanation is press because I understand everything. If you say some reason you are given, I understand from where you are giving. So here we can say the pressure does not depend. Here we can say pressure. The what is the reason? If they ask, we can say pressure does not depend upon the shape of container. Upon the shape of container. Fourth option is correct. I understand. But why it is not why pressure is same? Because the two containers are different in their shape. One looks little more wide, and other is little less wide. But we know that pressure does not depend upon the shape; it only depends upon the height, and height is same. So we can conclude that the pressure will remain same. Question number 5. Let's come. Question number 5. It says that container holds two immiscible liquids of density rho and 2 rho as shown in the figure. What is pressure at the bottom of the container? This is also a very good question. If you have two liquids, two liquids means you have to write, you have to know the height of both type of liquid. Like here, if I say this, this is one liquid. Let's suppose in this is one liquid here, and this height is also given as h, and density is given rho. And here is one more liquid we can take, and this is also h, and this is 2 rho. So we know the formula at for the pressure at the base is rho gh only. But at this point, if I say A, what is the pressure at the bottom by the liquid? By the liquid, they are not saying. They are saying that, uh, okay, the pressure, let's suppose atmospheric pressure, if I take as P naught, that is always there. And pressure for rho part will be up to height H only. So this will be rho GH. And then pressure for 2 rho will be again for next height density is 2 rho. So I have to add for this row height density is rho, for this height density is 2 rho. So I can say 2 rho GH. So we can say PA is equals to P naught plus rho plus 2 rho is 3 rho G. It means that try to find their individual pressure. This pressure is P1, this pressure is P2. So try to add the pressure P1 plus P2 at the bottom. It may be more than 2 also. If there are 3 liquids, we add all 3 pressures. Understood, Neil?
Yes, sir. Yes, sir. Yes, sir. Done.
Yeah, just a minute. Hello. Yeah, good morning, sir. Please. Yes, sir. Why? Because they are having annual exams, sir. Okay, then today online class. No, no, there is no online class also. They're not accepted. Okay, then what about their test? Today test was there, no? After 24th only we will discuss. After 24th only will explain 2, 3 classes where we'll take it, and then we will use the offline paper. Okay, sir. Okay, no problem. Thank you, sir. Thank you, sir. Sir, convey my wishes to your missus. Yeah, yeah, sure, sure. Started a course. You also supported, sir, because that I told na that morning first class I could not come because he was going for some classes. But yeah, I told you that now the result came, she got qualified. Yeah, yes, sir, yes, sir. And she can practice, sir, but she will join, I think, first. Some experience she will take and then she will. Yes. Correct, 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 correct. Yes, 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 sir. Correct. Thank you, sir. Very tough. Sir. Okay, sir. Thank you. Bye, sir. Thank you. देखो ये भी आपको एकदम समझ में आ जाएगा। क्वेश्चन नंबर 6 सॉरी 8, इसमें भी कुछ सॉल्व नहीं करना है, तुरंत आपको आंसर आ जाएगा समझ में। और खुद से आंसर देने की कोशिश करो। Equal volumes of liquid is poured into a vessel having some same cross sectional area at the bottom. Pressure of the liquid at the bottom is maximum. किसमें ज्यादा लगता है आपको बॉटम पे मैक्सिमम प्रेशर होगा या सब में सेम होगा? आप ये 3 कंटेनर देख के कोशिश करो बताने का। नहीं, इसमें भी देखो तो शेप का फर्क है ना तीनों में, अलग अलग
हाँ,
शेप है। लेकिन
बट
क्या
बेस का लेंथ सेम है।
हाँ, प्रेशर शेप पे डिपेंड करेगा क्या, पहले ये सोच के बताओ। यहाँ पे देखो एक चीज ध्यान दो, इक्वल हाइट नहीं दिया हुआ, दिया है क्या?
नहीं
इक्वल
सर।
इक्वल वॉल्यूम दिया हुआ है। इक्वल वॉल्यूम का मतलब क्या है कि जैसे कि ये यूनिफॉर्म लगता है, यूनिफॉर्म लगता है, मतलब यहाँ पे भी एरिया ऑफ क्रॉस सेक्शन ए है और यहाँ पे भी एरिया ऑफ क्रॉस सेक्शन ए है। तो ये सब कुछ हाइट मान लो, इसमें H1 है, इसमें H1 है। लेकिन दूसरे में क्या किए, दूसरे में हम लोगों ने क्या किया कि कंटेनर को थोड़ा सा ऐसे ऊपर वाइड कर दिया, नीचे वही एरिया रखा। देखो ये एरिया इसमें भी ए है, लेकिन यहाँ पे एरिया आपने थोड़ा सा बढ़ा दिया। लेट्स सपोज आपने ये एरिया इंक्रीज कर दिया, अब ये एरिया बड़ा हो जाएगा तो क्या हो गया, यहाँ पे हाइट थोड़ा कम हो जाएगा ना, क्योंकि ये तो ज्यादा बड़ा कंटेनर आपने ले लिया, इसका हाइट ज्यादा है, तो ये वॉल्यूम, ये हाइट थोड़ा इसमें कम हो जाएगा नहीं। अगर
हाँ सर।
बड़े बर्तन में कोई सामान, कोई पानी रखो तो उसका लेवल कम दिखता है ना। और तीसरे में आपने थोड़ा सा इसको छोटा लिया है, तो छोटे ग्लास में अगर आप वही पानी रखोगे ना, एक पानी आपने लिया है बड़े ग्लास में, वो कम लेवल तक दिख रहा है, लेकिन छोटे में अगर लोगे ना तो थोड़ा सा हाइट उसका बढ़ जाएगा, है कि नहीं? क्योंकि ऊपर आपने यहाँ पे कम हाइट लिया है, कम एरिया लिया है, नीचे एरिया सेम है बट ऊपर कम लिया है, तो ये हाइट यहाँ पे ज्यादा हो जाएगा। यानी H3 जो है वो मैक्सिमम हाइट बताएगा, जो ये कंटेनर आपने छोटा लिया है C, सो H3 विल बी मैक्सिमम। एंड इसलिए हाइट पे डिपेंड करता है प्रेशर, इसीलिए प्रेशर विल बी ऑल्सो मैक्सिमम, pressure will be maximum in case of C. Understood?
यस सर।
Pressure will be maximum in case of vessel C. Understood?
अंडरस्टूड।
Good. क्वेश्चन नंबर 9 कहता है, इट ए बैरोमीटर ट्यूब रीड 76 सेंटीमीटर ऑफ मर्क्यूरी। 76 सेंटीमीटर ऑफ मर्क्यूरी मतलब डेंसिटी, आपको मर्क्यूरी का प्रेशर का फॉर्मूला में मालूम है, रो जी एच। ओके, सो रो आपका हो गया डेंसिटी ऑफ मर्क्यूरी, जी तो मालूम है हमें, और एच यहाँ पे दिया हुआ है 76 सेंटीमीटर। इफ द ट्यूब इज ग्रेजुअली इंक्लाइंड एट एन एंगल 60 डिग्री विद द वर्टिकल, keeping the open and immersed in the mercury reservoir, the length of the mercury column will be 4n। अब देखो, पहले मर्क्यूरी का जो था वो ऐसे इस तरह से आपने रखा था, तो हाइट जो है, इसमें जो हाइट है मरकुरी का वो है 76 सेंटीमीटर। इसमें ये हाइट है 76 सेंटीमीटर। अब कहता है कि आपने वर्टिकल के साथ इसको थोड़ा सा टिल्ट कर दिया है ना, इस ट्यूब को आपने थोड़ा ऐसे टिल्ट कर दिया वर्टिकल के साथ। और कितना एंगल बन रहा है वर्टिकल के साथ, ये एंगल दिया हुआ है 60 डिग्री, ये एंगल दिया हुआ है यहाँ पे 60 डिग्री। अब इस कंडीशन में क्या पूछ रहा है, लेंथ ऑफ द मर्क्यूरी। अब यहाँ पे देखो, अब इसमें मर्क्यूरी का लेंथ कहाँ तक जाएगा ऐसे, तो आपको पता है कि हाइट सेम होना चाहिए, हाइट को शेप से कोई मतलब है नहीं कि आपने स्ट्रेट रखा है या एंगल पे रखा है। तो यहाँ पे भी यही हाइट चाहिए, यहाँ पे भी आपको हाइट यही रहेगा, हाइट में कोई चेंज नहीं होगा, ये हाइट। लेकिन आपसे लेंथ पूछा जा रहा है, आपसे लेंथ पूछा जा रहा है। तो हम कैसे कर निकालेंगे इसको, ये 60 है तो ये भी एंगल 60 हो गया। हम कॉस का ले सकते हैं, कॉस 60 डिग्री अगर हम लेंगे तो बेस हो गया एच एंड लेंथ हो गया एल। हमें एल बताना है तो एल हो गया एच डिवाइडेड बाय कॉस 60। कॉस 60 को आप 1/2 ले सकते हो, यानी अब जो लेंथ होगा वो 2 टाइम्स ऑफ एच हो जाएगा। नाउ अभी लेंथ कितना था, 76 सेंटीमीटर था पहले। अब लेंथ कितना है, 2h, 2h मतलब 2 × 76, ये हो रहा है 152 सेंटीमीटर। लेकिन आपसे n का वैल्यू पूछा जा रहा है। n हम यहाँ पे लिख सकते हैं, जो भी हाइट है उसको 4n से अगर हम कंपेयर करें, 152 is equal to 4 times of n. So I can find n equals to 152 by 4, and it should be 4, 3, 12 and 8. I think 38 is the correct answer. That is the value of n. कंसेप्ट समझ में आया इसके पीछे नील?
हाँ सर, सर समझ में आया।
हो गया नील?
हाँ सर, हो गया।
तो आप एक बार अपना कुछ क्वेश्चन प्रैक्टिस करो और मुझे भेजो कुछ सेट, ताकि हम एक दिन और प्रैक्टिस करें। इसके बाद कौन सा चैप्टर हमें पढ़ना है? ग्रेविटेशन है तो हो गया ना, क्या बचा अब? हीट एंड थर्मोडायनेमिक्स क्या चल रहा है अभी आपके सेंटर में, क्या चल रहा है?
इस सेंटर पे अभी थर्मोडायनेमिक्स शुरू होने वाला है। जो थर्मल
हम्म।
प्रॉपर्टीज अभी ये खत्म होने को है।
तो थर्मल प्रॉपर्टीज हम शुरू करें नेक्स्ट क्लास में।
ठीक है सर, ठीक है।
ठीक है, ओके बाय।
बाय सर।